which are basically trig statements that are always true. This old chestnut. One. Deal with the unit circle here. How did we come across this quite a bit so far? And we drew a triangle like this in the unit circle. We'd be able to get, let's say this was angle theta in here. We should be able to get that point. What would that point be in general? The x-coordinate would be cosine theta, and the y-coordinate would be sine theta. Fantastic. If we just took that out as its own right angle triangle, then that means that this length here would be cosine theta. Remember, cosine is just a ratio, it's just a number. But this number would definitely be less than 1. 1 is the hypotenuse. I can say that's 1. That length is cosine theta. This angle is theta. And this angle is sine theta. This is the triangle we're always working at off in the unit circle. And we know that Pythagoras' theorem can happen here. This is a right angle triangle. So cosine squared plus sine squared equals what? 1 squared, isn't it? Pythagoras' theorem. Okay, that's the first trig identity. It's always true. Cosine of an angle squared plus the sine of an angle squared will always equal 1. And then there's a couple that you can very quickly glean off this. Sine squared theta, 1 minus sine squared theta equals cosine theta squared theta. Is that right? Oh, I might got sine wrong. 1, 2 way that. No, that's not right. Other way around. Oh, sorry. Is that right? Cosine theta is 1 minus sine squared. And other rearrangements such as that. So just subtract sine squared from both sides, and you get that, and you get the same for cosine squared. So there's always that relationship between sine and cosine. And there always is a direct relationship between sine and cosine. So we may have noticed so far that sine and cosine are kind of opposite each other a little bit in a way. That when we have sine of 30 degrees or pi over 6, Bella, what's sine of pi over 6? Sure?
No.
You're right.
Yes.
Sine pi over 6 is half, and cosine 60 degrees pi over 3 is Jonathan? Also half, yes. Coincidence?
No.
Okay. Why not?
Well, Mr. Giddy told us that they like swap. So like the side on your table, the numbers they were backwards for sine.
Oh, is that going to be true for all angles though, or is it just these known ones? Just the known?
Maybe not.
You have to find out, don't we? No, I'm not just. I'm not comfortable just saying that some are swapped and some are not swapped. So let's pick one that we don't know. What's sine 40 degrees? Or what's that pi over what? That's a very good question.
No, that's 40, not 45.
What fraction of 180 is that? 40 out of 180. Is it 2/9? It's 2/9. So 2 oh, no. Okay, so that's it in radians. Okay. Well, even right, cosine 50, would that be the opposite one? You can work out that if you want. What's cosine 50? It won't be what? It won't be the opposite? We don't know yet. We're going to use a calculator to find out. I think it's 5 pi over 18, is it? 180 is pi, so that'll be the ratio. So 180 degrees, 50 out of 180, simplified fraction. Okay, we'll type into a calculator, use the degrees. Type into a calculator, make sure your calculator is in degrees. Have to be sure of this. As to get it says it's just the opposite. Maybe it's not right. Which modes, radians, degrees. And do cosine, well, 50 as cosine first. That's 0.623, approximately 0.643. And sine 40. Oh, that's the same number. Oh, look at that. Good thought. But it's just these two and these two. And all other angles then wouldn't have that property. Yeah. Want to change your answer to the previous question, isn't it? If you said it was only specifically these angles that work in that way.
I said it could also be.
Oh, could also be. Oh, I missed that. Okay. Well, it does seem like there's this relationship. How could we write this relationship in a more mathematical sense, rather than saying that every time it's kind of the opposite cease? What am I doing here? I'm saying that. Well, 40 and 50 add to what? 90. Okay. So it's all and 30 and 60 add to 90. So how do I represent that? So let's say sine theta is equal to cosine 90 minus. Okay, well let's use that. Comfortable with that? There's an identity. Is the same true for sine theta or cosine theta then? Can I say cosine theta is also sine of 90 degrees or 90 radians? 90 radians, pi over 2 radians minus. Okay, is that what we just found? Are there any problems here? No problems. Everything's fine. Everything's fine. Okay.
Define.
So, trying to figure out the.
Should I write that down or not?
Oh, the old note taking. Take away.
We want clause that means it's not on.
Yeah.
No, I guess you need to think about it. Just make sure that what we've done is what I've written here is what we've just done, and that'll always work. So what was this we did here first? We said here that sine 40 is the same as cos 50. And using my formula over there, sine 40 equals cosine 90 minus 40. That check out? That what happens? That's using my formula over there. Theta was 40. Seems to check out. What about the other way around? Cosine 50 is equal to sine 90 minus 50, which is sine 40. I think we're okay. So far, so good. What happens if it's over 90? Panic? Okay, cool. Go with that. Is there anywhere cosine equals the sine value then? Because there seems to be a lot of times you're going to hit the same number. 45 is exactly, yeah. But even like where one's positive, one's minus, any swaps we can do there. And cos is anywhere that maybe I'm not writing this very well. Any points along this circle that you get the same values. For instance, yeah, cosine 60 is the same as sine 30. Does that happen in the other quadrants? Because there's negatives, that's what I'm talking about, more than 90 degrees, because a lot of negatives and positives going on. Not always going to be the same. Is there any generalizations we can make there? There are some. Where there's sine negative angles in. No, maybe not. Just tell you. Okay. Let's look at some examples, and then maybe it'll become a bit clearer. So this is the kind of stuff we get. I'll write these on the whiteboard for those online. So we have a couple of identities. This one from Pythagoras, and those two up there from Lenti, and then the rest of them we're not sure. We'll come up with some more. So here's the first question. We want to, and this will always be simplified for the moment. Then eventually we get to solve. It's a bit like algebra. We want to make sure that the same rules apply in algebra. 3 times cosine theta plus 4 times cosine theta. Is that okay to write the answer 7 cosine theta? Yes. Cosine theta will always be that same number. If this is cosine theta and this is also cosine theta, no matter what it is, positive or negative, it is just a number that can be subbed in. So if there's 4 and 3, yes, they can be combined. Well, that's okay. So you treat this a bit like x. This is an x. 3x plus 4x, 7x. You can start to think about it when you're trying to manipulate them. Yeah, it's just another variable. So that leads us to the second question that's on screen. And that is it okay to do tan alpha? And you'll start seeing these alternate symbols for angles, alpha and beta, a lot from now. Is tan alpha take away 3 tan alpha? Is it okay to write the answer minus 2 tan? Yes. No thing that would state that these two, if it's the same angle, which it is, could ever be 2 different values. So therefore they can be combined like in algebra as if they were x's. Okay. That's the first 2 done. Good. So easy. So easy so far. This is where I was alluding to. Sine negative theta plus 2 sine theta. Now these obviously can be simplified, otherwise it wouldn't be in the be a question. Well, maybe sometimes they do throw in triplets, but what can this be simplified down to? Sine negative an angle. How is that related to its positive buddy? That's what it's saying. How can these two be combined? A sine negative and a sine theta. This might require us to have a little look at our unit circle. So let's say negative theta. Let's say this is negative theta. This is then positive theta. Same, whatever same size it is. Let's say that our value for sine theta, well, let's go back, is a half. Let's say it's this. Oh, I've forgotten again. What angle gives us sine a half?
30.
30, yep. So that's 30 degrees or pi over 6. Gives us sine a half. Now, sine negative theta would have to be, well, this would be negative 30 degrees or going backwards pi over 6. What would that value be here? Be minus that, wouldn't it? Be backwards. Be down on the y-axis, minus that. Okay. Can that relationship, will that always be the same relationship if theta is 60 degrees or pi over 3? That'd be root 3 over 2. And minus would be minus root 3 over 2. So could we change this then to actually, in fact, it's the same as sine theta, but just with a minus? Yes, you can. That's exactly what it is. Because it's a reflection in that x-axis. There is this relationship between sine negative theta and sine positive theta. Combined here, and we'll put the relationship down here in a second. These two now, I know is just sine theta. Two of them take away one that will just be sine theta. So that relationship is that's the answer. This is the relationship. Sine negative theta is equal to minus sine theta. And vice versa. And there's one with cosine as well. Cosine negative an angle. How is that going to be related to the original angle? Is it also minus cosine? Yeah. Could be, but let's have a little look. So if we know theta, this time we're looking at cosine theta. So let's say if we're looking at, well, let's do pi over 6 again, or 30 degrees. That'll be root 3 over 2, of course, we all know that. Minus would be here. Is that negative root 3 over 2? For cosine? No, because cosine is on the x-axis. So it's still that 3 over 2 point. Remember, this is y-axis. When we're dealing with sine, cosine, this is cosine, this is sine. Cosine deals with the x-axis. So moving from here to here is the same. So therefore, I can say that this is the same as its positive value, just straight up the same. They're interchangeable. What's the, well, perhaps not the obvious question. What happens beyond 90 degrees? Is the same principle allowed and applied? Or is it just the same? Well, let's have a little look. Whatever cosine's value is here, whatever it is, it's going to be minus, isn't it? And its reflection buddy here is also going to be minus. So that still applies. It's going to have the same value. And what about sine? Well, whatever its answer here is going to be plus, and its buddy's reflection is always going to be minus. So it's always going to be, so you see the way it changed. This one has the opposite sign, this one's the same sign. Same answer. Okay, that's that first one done on the board. Let's do the second one from the board. So these are the identities, I suppose, or the key points to take away. Part B then is asks us to simplify this. Pi over 2 take away theta. All over, oh no, pi take away. Our unit circles here, and the answer over here. Cosine 90 degrees take away theta. What can that be rewritten as? Sine theta, yes. It's up here. Sine theta. Awesome. What about 180 degrees or pi take away theta? These are final two that we're trying to create. What happens when I do cosine pi minus theta and sine pi minus theta? Or what happens, do we think? Cosine pi take away theta will always be the same as something.
Maybe
2 sine theta. See if you're right. Like that. Okay. I'll put it in green because I don't want you to write it down. That's not the case. Okay, let's think about it. So pi takeaway. So let's say this is theta. Pi takeaway theta is going to be, well, if this is theta, this would be theta as well. It's let's do it in a different color. It's this angle all the way to here, isn't it? That's pi takeaway theta in blue. Well, we use this for our reference angles and stuff, using our reference angles when it's in the second quadrant. And this is not the same value as this, it is just the negative version, isn't it? If theta is the same here and here, although it doesn't look like it on my diagram, if cosine theta is a half here, so let's put in the point. There's going to come sine as well. The whole point, if this is, let's do pi over 6 again. This is pi over 6, so theta is pi over 6. Cosine of pi over 6 is 3 over 2, and sine is a half. This point over here is, isn't it minus root 3 over 2 and positive a half? Yeah? Okay. So what's my generalization here? Cos theta or pi minus theta, Laura, is? What has, this was the original answer. It has become this. Theta, its relationship to theta is just this. It is the negative version. 180 degrees take away theta will end us up here, which is direct relationship to theta originally, plus the opposite sign. Theta originally had this sign, positive root 3 over 2, and theta on the other side will have negative root 3. What about sine? Well, we can see the sine value will be the same. Now you were doing that and you didn't know you were doing it in the unit circle when you were getting those multiple values that had the same value, and if it was plus and minus, you would include both, and if it wasn't, you just pick for cosine, you pick this and this, find those angles. If this is confusing, it can be confusing, definitely. But there's your identities that you can have. I don't really all of them given in the format of it. Great. Yeah, none of them really. So these are useful but not crucial. The only one that's crucial is the Pythagorean, the cosine squared plus sine squared is equal to 1. That's crucial. These you can figure out yourself. But sometimes when simplifying, it's good to know them because it can make a question a lot easier rather than having to work out both cos 90 and cos the angle. So back to the question. To finish off this, what is cosine pi minus theta? Well, it is just the negative cosine theta. Sine over cos is tan. And I can simplify it down, right down to negative, because it's negative. One is negative, the whole thing is negative. I can simplify it right down to that. Is what it is. Okay. I have some more questions. I'm going to do most of the questions today again. Someday you guys are tired anyway, so. Okay. Let's try and use the Pythagorean identity to try and simplify and factorize some more questions. This is really just algebraic manipulation. And I'm going to try and simplify in trig terminology. 2 minus 2 sine squared theta. I want to simplify this. These will all be using the Pythagorean identity, which is sine squared theta plus cosine squared theta equal to 1. So I got to use that in some way to try and simplify it down. Simplify in general means if I have 2 terms, I'll try and simplify it down to 1. As simple as I can get. So I want to get these 2 terms down to 1. How can I do that? Using this. So there's a number there, sine there, there's no cosine there, but we do have a relationship between those two. Cosine squared theta is 1 take away sine squared theta. See that? And this just subtract sine squared from both sides. And that looks a lot like this, except for there's 2's. Let's factor out a 2. Oh, look. That is that. Done. That's it. That's all we can do. 2 terms, down to 1. Next one. You guys try. First, sine cubed. Yes. So here's 2 terms as well. These two. Try and get it down to just 1 term. All right. Yep. Sine theta as well. Anybody else? Okay. Let's have a little go. If you want to watch, you can watch me, or you can keep going what you're doing. Similar to this. This one I took out a common factor, as that was something I can simplify. I'm also going to do a common factor here. Sine is common to both. But this is actually saying, and we never write it like this. This is cosine theta, and cosine theta times sine theta is this. So I can take out a sine theta, it's no problem. I can factor out something. It's just multiplying by those, combine those two together. So I take out my sine theta, left with cosine squared theta from this one. And from this one, I'm left with just a sine squared theta. Because instead of multiplying by itself 3 times, it's just twice, because this one's outside, it's factored out. This is 1. Sine squared theta plus cosine squared theta is 1. So it's just 1 times sine theta, which is sine theta. When you say sine theta times 1 and then finish it off with sine theta, that's okay. But you're looking to get this in some form. It's another form of it, saying that it equals cosine squared. And it's simplified. So that's a lot easier looking than that. Okay, let's do the other ones. If you want to do these other ones faster than me, if you got to think you might have the hang of it. It's all just going to be using this identity. So go for it. If you're online, you can't do that. I will write them here. Okay, so first one, it's asking us to expand and then simplify cosine theta minus sine theta squared. Next one's asking us to factorize cosine squared alpha minus sine squared alpha. Next one is, oh, I can't read all that. It's tan squared theta minus 3 tan theta. I think it's plus 2. Next one. Okay, so go for those and see. Whichever ones you want to do. Give you a couple minutes, see how many you can do. Try and do. If you're not sure what to do, treat them like x's and y's. If it was x squared and y squared, all you know for sure is that cosine squared plus sine squared equals 1. Start the first one and to see if you can see it. So it squared would be it times itself. And do all those multiplications. You should end up with some stuff that you cancel. Second one, this looks like the difference of two squares to me. If you remember how to factorize difference of two squares. If you don't, the difference of two squares in general, if a squared minus b squared, then it can factorize like this. A plus b, a minus b. It's difference of two squares. Get that? This is only I'm doing the first steps here, I'm not doing the whole thing. This one is a quadratic. This is x squared minus 3x plus 2. What would you do? Do the same thing. Notice what the word is to start these. Factorize those two. This one, the first step I would probably do is take out that 2 again. The second step, I wouldn't change this to sine squared. I would treat this like 1 squared. Sine squared is all well and good, but you're still going to be left with 1 plus cosine theta at the bottom. You can make it actually simpler than that. That is also the difference of two squares. Like this. 1 is just 1 squared. Just take care of that again. This difference of two squares again. Okay, so I'll finish this first one. Start multiplying out. You should be left with cosine squared theta minus cosine theta sine theta. There's nothing I can do with that. It just is what it is. It's shoved together. Multiplied minus cosine theta sine theta again. These two multiplied. And the last two multiplied is going to be plus sine squared theta. Now hopefully you see that there's a cosine theta there and a plus that. Those two together will form 1. These two together from the Pythagorean identity. And there's 2 of these, so I can just say 2 cosine theta sine theta. And that is the answer. Anyone get that? Maybe not. Yeah, cool. Second one, difference of 2 squares. That's just straight up cosine alpha plus sine alpha and cosine alpha minus sine alpha. Is that done? Factorize as far as it can go. This one, anyone get an answer here? Or not an answer, factored it here? Minus 1, minus 2. So tan theta was it? 1 and 2 here. This times this gives 1 tan theta, or just tan theta. And this time this will give 2 tan theta. Need them both to be negative, don't they? Minus 1 minus 2 is correct. That's it factorized. There's no solving here yet. You will be asked to solve eventually. This one, I've done the first step. If I do difference of 2 squares here, that'll be 1 plus cosine theta times 1 minus cosine theta. All over 1 plus cosine theta. And perhaps you can see that that would cancel with that. We're just going to be left with 2 times 1 minus cosine theta. That's the answer there. Anyone get the answer to the last one? Very similar to this. This. Cosine theta minus sine theta still on top. This one can factorize the difference of two squares again. Cosine theta plus sine theta and cosine theta minus sine theta. And that one cancels with that one. So we're left with 1 over cosine theta plus sine. Final answer. Just simplifying, just trying to get them a bit neater, a bit tidier by factorizing. They all have to be factorized, well, besides the first one. Something else? Oh, there is some more for you to do. Oh. Quotes. Okay, here's some for you guys to do. A mixture. The one's question 1 here is like this style, and question 2 and 3 is kind of using this stuff. So do whatever you want to do. So if you feel like you want to do this style first, do this question down here. Online people, I will manage back now for you. Just give me a second.